So today we're going to be looking at convergence and divergence of normal infinite series. And what I mean by normal really is that they're simple looking and not very complicating. And so it'll be really easy to understand if it's converging or diverging. But let's look over some definitions first. So we say that the Sn is equal to the series right here. And this series right here is going from I to n. So it's a sum of all the terms together from I to n. And that's what it is. So just to give you a small example, I'm just going to show you what S3 is. So what is S3? So S3 is the sum of the terms from n equals 1 to 3, right? So in this case, if I were to write out what the sum is for S3, then I would say this is going to be, well, it's going to be 1 squared plus 2 squared plus 3 squared, right? And then all of this is going to be equal to 1 plus 4 plus 9. And what is that? That's 14. So in this case, S3 is equal to 14. It's very simple. But then we're dealing with infinite series, right? What we just did was a finite series, so let's take a look at something more complicating, which is an infinite series. So when we're doing something that's infinite, we're going to have to take the limit, right? So in this case, what we have is going to be something like this. So here we are going from I to infinity. And it's going to be an, where an is a sequence. But here, this is equal to not Sn, but because we're going to infinity, instead, we say the limit as big N goes to infinity of Sn. The big N for the S. Anyways, the most important part is here. If the limit that we take is a finite number, then what that tells us is that it is convergent. That series is convergent. But then if it's an infinite number or if it does not exist, then we say that series is divergent. So that's very important. So why don't we do an example here to see if this series is divergent or convergent. So right here we're given a series that goes from n equals 1 to infinity, and it's n over 3. So I'm going to use directly what the definition is, or what the formula is. I'm just going to use that formula and say the limit as n goes to infinity of what? In this case, I'm going to go and say the series n equals 1 to n of n over 3. And you're like, well, what is my Sn then? Well, Sn, in this case, is this thing right here. This whole thing I'm circling, I call this thing Sn, the sum of the terms from 1 to n. So that's my Sn. And it's in, as you can see, it's in a form that is in a series. But then you want to ask yourself a question. Can you really directly take a limit of a series? So a limit of n goes to infinity of a series. Can you really do that? And the question is no. We cannot really use our brain and say, okay, what is the limit of n goes to infinity of this series? So what are we going to do then? Well, we're going to use a formula. And we're going to change this series so that it is actually something that we can evaluate when we take the limit as n goes to infinity. And here is what I mean. I have a formula, and what this formula tells me is that if I have a number, I'm going to write it right here. If I have a series, that goes from 1 to n, and the function itself in here is n, or the sequence in there is n, then what I have is that I can use a formula for this. If you recall, in Riemann sum, you learned this is something called a power sum. So this thing right here is a power sum, and what the power sum says is that if you have a series that goes from 1 to big N of this small n right here, then the sum of all those terms are going to be n times n plus 1 divided by 2. And then, oh, isn't this perfect? What if I use this formula right here? If I use this formula, I can definitely use it here and then evaluate the limit. But first of all, we got to do something because this over 3 right here, this 1 over 3 that we have is kind of in the way. So what I'm going to do is factor it out. And if you didn't know, you can factor constants out of the summation, and you can also factor it out of the limit. So this is what I'm going to get. I'm going to get 1 over 3, the limit as n goes to infinity of n. And you're like, wait, hold on a second. I need to use the series. I can't just say n. So you say the series n equals 1 to big N of n. And now I can directly use this formula and say that, okay, this thing right here, this is equal to n times n plus 1 divided by 2. So I'm just going to substitute it right into my question that I have right here. And if I do that, then what I'm going to get is, this is equal to 1 over 3, and the limit as n goes to infinity, and again, this is going to be n times n plus 1 divided by 2. And then, now I can evaluate the limit. It makes sense, right? And the reason why it makes sense is because this is an actual value now, and I can just take the limit as n goes to infinity. I couldn't do that before because this was a series. So now I can actually do this, and I realize that as n goes to, the big N goes to infinity, I realize this whole thing right here goes to infinity. So this is going to be infinity. So where did we start from? We went from a series, an infinite series, and we said that this infinite series goes to infinity. So remember when I said that the limit, if I say that the limit is infinite, what do we say the series is? We say that the series diverges. So that means that this series right here, n over 3, n equals 1 to infinity of n over 3, this series right here is going to infinity, so it diverges. And that is it for the introduction for this session, and I hope that you have fun doing these questions, and feel free to watch the videos of these questions, and I can't wait for you to watch the next video. Thanks for watching as always.